So I will start discussing the first topic of Module 3, which is Introduction to Statistics. So now let's talk about statistics. So what is statistics? Statistics is a group of methods used to collect, analyze, present, and interpret data and to make decisions. The decisions that we make on a daily basis, we don't really have any precise or definite solution for those decisions. But statistics aims to provide you with such scientific and intelligent decisions, or what are known as educated guesses. There are two aspects of statistics. We have theoretical statistics and applied statistics. Theoretical statistics deals with the development, derivation, and proof of statistical theorems, formulas, rules, and laws, while applied statistics is the application of those theorems, formulas, rules, and laws to solve real-world problems. In our class, we are concerned with applied statistics and not with theoretical statistics. So, speaking of applied statistics, there are two types. We have descriptive statistics and inferential statistics. Descriptive statistics consist of methods for organizing, displaying, and describing data by using tables, graphs, and summary measures, while inferential statistics consists of methods that use sample results to help make decisions or predictions about the population. So let's first talk about descriptive statistics. Now, suppose you're a teacher and you have information about the test scores of your students in a statistics class. So all of these numbers that you have, the test scores of your students, this is called your data set. And the name of each of your students is called the element, and the score of each student is called an observation. So in the first place, these are your first few terms related to descriptive statistics. Notice that with these terms, we are describing our data. So what is a data set? Well, it is, as I mentioned earlier, it is the one that represents the scores of the students. Okay, so usually a data set is very large. As such, that data set is not very helpful in drawing conclusions or making decisions because it's very large and it's very hard to read. It is easier to draw conclusions from summary tables. So you summarize your data and you draw diagrams so that we can reduce the data to a manageable size, and we can calculate summary measures such as averages, right? Because if you're confronted with the entire data set, it may be very hard to read and it may be very difficult to interpret. That's why we have summary measures and we have the ability to draw graphs to visually see trends of your data. So this portion of statistics that helps us to do this type of statistical analysis, that is called descriptive statistics. Look at this, for example, right? You have a chart showing the top 5 phone companies in the Philippines. And apparently for the year 22, it is Realme. Okay. Well, right. So imagine if you were confronted with the large data set of this particular statistical uh, survey, right? And it would be very hard to see which phone company is number one if you are only seeing a list, right? But by converting that into a visual pie chart, it is easy now to see that the top smartphone company is Realme. You can also create a bar graph, no? And you can easily see that as of April 2022, the leading manufacturing company is Ginebra San Miguel. Sorry about that. How about inferential statistics? In statistics, the collection of all elements of interest is called a population. Okay, and the selection of a few elements from this population is called a sample. Well, a major portion of statistics deals with making decisions, inferences, predictions, and forecasts about populations based on results obtained from samples. Usually, it's very hard to collect data from the entire population, so we just obtain samples. For example, we may make some decisions about the political views of all college and university students based on the political views of 1,000 students selected from a few college and universities. So it is very impractical and virtually impossible to survey all students in all colleges and universities. So we just select a sample. Another example is we may want to find the starting salary of a typical college graduate. To do so, we may select 2,000 recent college graduates, find their starting salaries, and make a decision based on this information. Okay, so this is an example of a graph showing inferential statistics, right? So population versus sample. So suppose a statistician is interested in knowing the percentage of all voters in a city will vote for a particular candidate in an election, or the 2022 gross sales of all companies in the Philippines, or the prices of all houses in Davao. In these examples, the statistician is interested in all voters, all companies, and all houses. Each of these groups is called the population for their respective example. But in statistics, a population does not necessarily mean a collection of people. It can, in fact, be a collection of people or any kind of items such as houses, books, television sets, or cars. The population of interest is usually called the target population. So the population or the target population, it consists of all elements, individuals, items, or objects whose characteristics are being studied. The population that is being studied is also called the target population. But most of the time, decisions are made based on portions of populations. For example, the election polls conducted in the Philippines to estimate the percentages of voters who favor various candidates in any presidential election are based on only a few hundred or a few thousand voters selected from across the country. In this case, the population consists of all registered voters in the Philippines, but the sample is made up of a few hundred or few thousand voters who are included in an opinion poll. Thus, the collection of a few elements selected from a population is called a sample. So this is uh, like a visual representation of getting a sample from a population. So you cannot collect data for all members of the population, but you can just select a sample and you can analyze that sample. So what is survey versus census? So the collection of information from the elements of a population or a sample is called a survey. A survey that includes every element of the target population is called a census. Right? So census is if you're trying to collect to include all elements of the target population. Often the target population is very large, so in practice a census is rarely taken because it is expensive and time consuming. Usually to conduct a survey, we select a sample and collect the required information from the elements included in that sample. We then make decisions based on the sample information. Such a survey conducted on a sample is called a sample survey. Okay, so here are some more basic terms: statistics, element, or a member. An element or a member of a sample or population is a specific subject or object about which the information is collected. A variable is a characteristic under study that assumes different values for different elements. In contrast to a variable, the value of a constant is fixed. Observation or measurement is the value of a variable for an element is called an observation or a measurement. So more terms for descriptive statistics. More terms, data set. So a data set is a collection of observations, one or more variables. Variable is a characteristic under study that assumes different values for different elements. Oh, this was the same as the previous slide. Okay. How about this? Top 15 causes of deaths in the Philippines, percent of total. So cause of death here is the element or the member. And the cause of death percentage is the variable because it's changing, right? And each year the observation is the percent for a particular cause of death. So the combination of the element and the variable is what you call the observation or the measurement. So let's look at this exercise. The following table gives the number of dog bites reported to the police last year in 6 cities. Briefly explain the meaning of a member, a variable, a measurement, and a data set with reference to this table. So the members are the cities, Center City, Elm Grove, right? The variables are the number of bytes. The measurement is Center City 47, right? Elm Grove 32, Franklin 51, and the data set is the entire thing. A measurement involves the number of bytes per city. So that's your measurement. And the data set is the entire thing. What is the variable for this data set? Exercise 2. Well, the variable here is the GDP. And how many observations are in this data set? Well, we have 17 observations. How many elements does this data set contain? 17 as well, right? So, sources of data. The availability of accurate and appropriate data is essential for deriving reliable results. So these are just a list of where you can gather data. You can obtain it from internal sources, external sources, surveys, or even experiments. And here are some websites where you can get data externally, websites in the Philippines. And you can pause the video if you want to read. And other sources are healthcare institutions, educational institutions, financial institutions, the private sector, academic research. And basically, there are two kinds of sources of data. We have statistical sources and non-statistical sources. So if data is collected for official purposes, well, that is a statistical source. But if it is collected for the private sector or other administrative purposes, then it is a non-statistical source. And we also have types of data, primary data and secondary data. So as the name suggests, primary data are first-hand information collected by the surveyor. They are pure and original and collected for a specific purpose, and they have never undergone any statistical treatment before. Whereas secondary data is collected and published already, They can be used as a source of data and used by surveyors to collect data from and conduct the analysis. They are impure in the sense that they have undergone statistical treatment at least once. To collect primary data, you can do surveys, interviews, observations, experiments, focus groups, case studies, content analysis, diaries and journals, photography and video recording, and sensor data. And for secondary data collection, you can do either of the following as well. Finally, we can categorize data as either quantitative or qualitative. So data that is quantitative is a value or numerical measurement for which operations such as addition or averaging make sense. And qualitative describes an individual by placing the individual into a category or group such as a male or a female. We can categorize data as either quantitative or qualitative. Quantitative data is a value or numerical measurement for which operations such as addition make sense. Yeah, we did this already. Right, so which of the following data is quantitative or qualitative? Height, weight, age, these are quantitative data. Income as well. And the last two are qualitative. Okay, this is for another video because the video is too long. So thank you so much. How do we stop recording?